All right, guys. So we're gonna keep going in this video. Welcome back. So in this video, we're gonna look at a very specific kind of cash flows, that is annuity. So in previous discussion, we were only looking at one cash flow at a point. Either we have, or either we were calculating present value at time zero, or we were calculating a future value at time t. These are all cash flows. These are all just one cash flows at a time point. So what if we want to repeat the cash flows? So for example, if you look at the description in the slides, suppose we want to save for a car and we want to save $5,000 a year starting a year later. So what's going on here is that T is 4, right? So we have 4 years, 1, 2, 3. So in each year, we're going to add $5,000 to our savings account for the car. Okay. Okay, so how do we calculate the future values, let's say, of all these cash flows if the return is 4%? So that's basically saying if I put $5,000 at the end of year 1, I should be able to invest from year 1 to year 4. That's a total of 3 years. So I'm going to be able to calculate the future value of this amount of money 3 years later. And I should also be able to calculate the future value of this $5,000 2 years later. And lastly, we calculate the future value of this $5,000 that you saved at the end of year 3 1 year later, right? So because from the end of year 3 to the end of year 4, you have 1 year. So that's the plan. So we're gonna try to calculate all these future values because we're gonna invest these at 4% for the respective number of years, and we're gonna see how much money we're gonna end up with. So this is the cash flow we were looking at, okay? And I'm formally putting down the definition for annuity. So annuity is a kind of financial instrument that pays equal amount of cash flows regularly during a certain period. So you don't have to worry too much about the instrument itself, but for now, what we really care about a lot is the pattern of cash flow. Because in annuity, you receive equal amount of cash flow repetitively each period, and every period has the same length. That is, you receive or you save $5,000 at the end of each year, and between any two $5,000, it's a year. So it's not like half a year between the first and second, and then 1.5 year between the second and third. No, so they have equal payments, equal interval over a certain period of time. So if we want to calculate the future values of each one of them, the answer is pretty simple. You just need to use the amount of money, 5,000, that's there, times 1 plus 4% raised to the power of number of years you're investing this. So for the first $5,000 you saved at the end of year 1, you're going to invest it for 3 years. From year 1 to year 2, that's year number 1. From year 2 to year 3, that's number 2. From year 3 to year 4, that's number 3, right? So a total of 3 years of investment. And then if you look at the second $5,000, you're going to see that you only invested for 2 years, but the formulas are the same. And if you look at the $5,000 you save at the end of year 3, you only invested for a year. And then if you look at the last $5,000, you basically invested for 0 years. You don't really got to invest it, right? Because that's exactly at the end of year 4. You don't really have time beyond that. So you don't get to invest it. So the total future value is 21,232.32. So that is more than the summation of these 4 $5,000 payments, right? So the additional amount is the interest you earn on the investment. So there's a formula that you can use if you like to calculate the future value of annuity that is listed here. So payment is essentially 5,000. So if I want to, plug in everything, so future value equals to the payment, which is 5,000 times 1 plus 4%, 0.04, raised to the power of 4, okay, minus 1, okay, divided by R, which is 0.04, okay. Okay, so 4, that is T, so it's basically saying you have 4 years, but this formula presumes that you receive equal amount of payments at the end of year 1, 2, 3, and 4. Okay, so I'm just putting it here again, but I want to emphasize that this formula, the formula at the bottom, is just a mathematical simplification of the one on the top. Okay, so basically what I'm saying is, to put it in our context, the one on the top says the future value equals to the payment times 1 plus R to the power of 3, right? So this is the payment you saved at the end of year 1 plus payment times 1 plus R to the power of 2. This is the $5,000 you saved at the end of year 2 plus payment times 1 plus R to the power of 1. That is the $5,000 you saved at the end of year 3. Lastly, we plus payment times 1 plus R raised to the power of 0. So that's the $5,000 you saved at the end of year 4. So it just have to be like this. Okay, so that basically saying your payments must be received at the end of each year. You just have to invest over equal intervals. You have to have the same return over each interval. So this long summation is equivalent to FV equals to payment times 1 plus R to the power of 4 minus 1 divided by R. Okay, so that is the future value. Okay, so what we said, I was trying to emphasize that in an annuity, and to be able to use the formula for in an annuity calculation, you have to receive or make all the payment, PMT, at the end of each year, right? But what if we want to receive annuity at the beginning of each year? What if there's such an instrument that's going to give us beginning of period payments? So this is called annuity due. So if you receive all the payments at the end of the year or at the end of each year, it's called an ordinary annuity. So the only difference between annuity due and ordinary annuity is that in annuity due, all the cash flows are received 1 period earlier. For example, if you look at the first cash flow of between ordinary annuity and an annuity due, you're going to see that in an ordinary annuity, the first cash flow is received at the end of year 1, but in an annuity due, the first cash flow is received at the beginning of year 1, which is year 0, okay, right now. And if you look at the second cash flow of an ordinary annuity is received at the end of year 2, but the ordinary in annuity due, the second cash flow is received at the beginning of year 2, which is equivalent to the end of year 1. Okay, so how does this factor in our future value calculation? So basically, if you wanna take a step back and look at the cash flow, the timeline, you're gonna see that we have $5,000 that's gonna be received at the beginning each year, or every $5,000 is shifted 1 period back. So what you see in the future value calculation here is that this number of years is 4, because we're going to invest for 4 years for the first cash flow rather than 3. because we're receiving the cash flow at the beginning of the year rather than the end. So we actually invest one more year for all these 5,000 cash flows. So which leads to a higher future value. But in terms of calculation, essentially what we do is we just calculate as if it is a ordinary annuity, but in the end we multiply with 1 plus r because we do invest every cash flow one more year. So that's it for this video. If you have any questions, let me know.